Hello, Professor and class. My name is JTurull, and this is my live presentation of the ECT295L DC voltmeter project. The goal of this project was to simulate, build, and program a fully functional DC voltmeter. The completed device will be able to read a measured value from 0 to 20 volts DC and have the measured value be displayed on the organic light-emitting diode display, also known as an OLED display on the ARM I/O board. In order to successfully complete this project, I used two software programs. These were Multisim version 11 and LabVIEW 2010. I also had to use many hardware devices and components: an ARM I/O board with an OLED display, an ML2010 trainer power supply, a digital multimeter, and components consisted of a Zener diode, several capacitors and resistors, an op-amp, a 2K ohm potentiometer, and a lot of wire. The first step of this project was to use Multisim version 11 to simulate the circuit. Once the simulation was completed, I used an XMM to ensure I would get 3 to 3.3 volts at pin 1 of the op-amp. Upon verification of the voltage, I determined the circuit was functional and I could move on to physical construction. Using all of the previously mentioned hardware devices and components, I built my circuit following the schematic created during simulation. I then used a digital multimeter to ensure I had the 20 volts to be measured, the 5 volts that will be applied to terminal J2, and the 3.2 volts at the output of pin 1 of the op-amp using the potentiometer to adjust the gain. I then connected the 5 volts, ground, and the pin 1 output of the op-amp to the J2 terminal of the ARM board. The third step is to connect the ARM board via a USB cable to my computer. I then open the project file to launch LabVIEW and compile and download the program to the ARM board. Once the program was running on target, I was able to view the measured value on the OLED display and begin testing. The final step is to test the voltmeter by using a digital multimeter to compare the voltage to be measured with what is displayed on the OLED. I did this measuring multiple voltages to ensure my range was accurate as well. Fortunately, I didn't have to make many modifications to my project. I only had to make one hardware modification. Because of the placement of my circuit on the breadboard, I had to add a few extra wires to connect power to each individual component on one side of the circuit. I also only had to make one modification to the software. The first time I tested my voltages, I realized that the OLED screen was showing my voltages approximately 3.2 volts lower than the voltage to be measured. I then had to adjust the formula within the program to ensure that the OLED display accounted for the offset. The first problem I encountered was having to attain the necessary parts, as the op-amp and diodes did not come in the parts kit. I found the Zener diode at my local Radio Shack and ordered the other two parts from the digikey.com website. Once I completed building my circuit, I was not getting any voltage to pin 1 of the op-amp. After testing every component to ensure they were working properly, I decided to review the datasheet for my op-amp. This helped me to realize I had placed the op-amp backward on my circuit board. After fixing the op-amp, I still wasn't getting the correct voltage. I had already verified that all of the components and wires were working properly. I then noticed that my diode and Zener diode looks exactly the same, and I could have easily switched them. Voila! After switching them back, my circuit was working perfectly. I don't see that many improvements need to be made. Some small suggestions are that the school make the components not supplied in the parts kit available in the bookstore, or supply the students with a trusted component website to attain them. Another improvement would be to supply or make available a case that the completed circuit can be securely placed in. I am sure, like myself, other students do not have offices or studies and must work on their projects where it is subjected to animals, children, and many other things that can cause damage and ruin our ability to complete the projects. In conclusion, I was able to successfully complete the project. I was able to complete each portion of the project, troubleshooting as I went, identifying each issue and resolving the issues successfully. This project challenged me to apply all of the knowledge and skills I have obtained while studying electronic and computer technology at DeVry.